Thanks for the introduction, Joshua. Thanks everyone else here for coming. I hope you still have some brain capacity left after all of the other cool talks today. If not, there will be lots of pretty pictures just to look at during the session. And yeah, I will be talking about virtual manipulatives. I gave a similar talk during MathsConf Mini a few weeks ago, and we will sort of be building on top of that and exploring slightly different things. So yeah, check out the previous video that's available on the Complete Maths website. But also, if you haven't seen that, you won't be missing any prerequisites. I'll be sort of explaining all of the features and UI again. And there are lots of online platforms for virtual manipulatives. We'll be using Mathic's Polypad, and it's completely free to use. And I would encourage you, if you can sort of fit two screens on your, two windows on your screen at the moment, to try to follow along. It's free to use. You don't even need to sign up. Just go to mathicon.org/polypad. And I'll also put the link in the chat so that you can click on that. 1 second. There we go. Aha, so some weird highlighting happening on my screen, but hopefully that all works. So yeah, this is Polypad. As you can see, I will delete the background here and open the sidebar on the left here. And you can see we have many different tiles and components and widgets to play around with. And you can just drag them out onto the canvas like this, or you can click on them and they appear in the middle of the canvas. Down here, you can see we've got a few different tools related to what's currently selected, and you can see the item that is selected sort of has a black outline and a handle at the top. So I can click copy and then rotate the tile around and snap it there. And you can see both for rotation and for moving things around, all of the tiles snap to each other to make it really easy to create different patterns or tessellations. So we've got 3 squares here. I think we can fit an equilateral triangle in between here. There we go, like this. Okay, so we've got a ring here, which I kind of want to continue, but rather than copying all of the tiles individually, I can drag to select multiple tiles at once. You can see right now I have the red hexagon selected, and I don't really want that. So if you hold down the Shift key on your keyboard, you can just toggle individual items on and off in the selection. So if you just want to select very specific tiles, hold down the Shift key, click on all of the ones you want to select, click copy down here, or just the C key on your keyboard, and it will create a copy. We can rotate all of those together, drag them into place. And we have the beginning of a tessellation here. And if we just select these tiles in the corner, we can just, oh, that didn't quite fit in there. We can just keep continuing the pattern like this. You can drag the entire canvas around by using 2 fingers on your trackpad or scroll wheel on your mouse, and you can also zoom in and out using these buttons on the side, or just by pinching and panning on your trackpad again. So yeah, this is sort of the basic interface for adding and moving these tile rounds. I'm sort of following the chat on the side of my screen, and I'll respond to some of the questions there as well. It is not possible to resize these tiles. They are specifically designed to sort of fit together nicely, but there are ways around that, and I'll cover those later. For now, so here on the left, we can see these polygons are really just the tip of the iceberg. There are many different other tiles that we look at later. Down here, you've got a toolbar. Right now, I've been using the Move tool to add and move these tiles. There are also drawing tools, so I can draw with a pen or stylus. We can change the color there as well. If you want thicker lines, or if you want to highlight text, or if you want a ruler and sort of draw straight lines. Lots of different tools. We have some geometric construction tools. So we can construct a triangle like this, for example. Let's switch to a different color maybe. And If I select one of these sides, you can see new options appear. So there are lots of different construction tools for specific tools. We can construct a perpendicular bisector, in blue in this case. And if we construct all three of them, they happen to meet in a point, as you probably already knew. And let's maybe make the tool yellow, and then we can simply switch to the circle tool here and drag a circle from the intersection point to one of the vertices of the triangle. And all of this is dynamic, so I can move the perpendicular bisectors or the points around, and everything updates just like in any other dynamic geometry software. So we've got lots of other tools as well. You can add some text, circle like this if you want labels, for example, and again, resize that as necessary. We've got an eraser if you want to quickly get rid of strokes and tiles, and you can also upload images. Upload images is one of the very few features that require you to be signed into an account. So you can see here in the corner, I am signed into a Mathicon account, but again, they're free to use and should just take a couple of clicks. You can also just drag and drop images onto the canvas if you don't want to use the upload feature. So here I've got a folder with a couple of things. Oh no, now it's moving my sharing area. And I can, I'm not sure why Zoom won't let me select these tiles. There we go. So I can select different images and just drag and drop them onto the canvas, and they get uploaded, and then I can, oh, I'm still on the eraser, resize them as necessary. Up here, there are a few more settings and options. Most of those should be obvious. There's a full screen button. You can undo and redo. You can also use Command or Control Z and Y to undo and redo. There are lots of different grid settings if you want a coordinate system background or isometric grids or checkerboard. A few other settings. You can very quickly share the polypad to Google Classroom or social media, or just copy the link as necessary. And or download the entire canvas as a PNG image. But I actually, now that we sort of understand the interface a little bit, let's start from scratch, and let's close this whole geometry sections and go to number tiles. That's where I wanted to start. And you can see here we've got these number tiles, and like the polygons, we can drag them out onto the canvas. So here I've got 10 little squares in a row, for example, and we can add 10 more, and we can add one more, and let's copy this a couple of times. So now I've got 24 tiles in total. And like I mentioned before, if you select tiles, the buttons down here might change depending on the type of tiles you have selected. So with these number tiles, I've got a merge button, and I can merge all of these into one continuous block. Now I can use the handle here to resize this block and change the number of columns. So this is great for talking about divisibility or prime factors, or remainders, factorizations. For 24, we can make it in one big row like this. We can make it as 2 times 12, or 3 times 8, or 4 times 6, or 6 times 4, and so on. So a great way to think about factorizations. And of course, students should be able to see, if I make a copy of this, 4 times 6 is the same as 6 times 4, just rotated. If I select one of these blocks, I can split it up into the individual tiles again, and maybe I want to delete one of them and then merge the others back together. So now I have 23 tiles in this block, and if you resize, we can see that it doesn't seem to be possible to make 23 into a rectangle at all, except sort of one big column or one big row, because 23 is a prime number. So a great way for students to discover prime numbers. Let's start with the 100 block. Again, split it up, delete some of the ones at the end, maybe, until we have 91 left. And I'm not sure if anyone can remember the prime factorization of 91, but using these blocks, it's relatively easy to find that it is 7 times 13. So these number tiles are great for students to play around with on their own when doing homework or learning remotely or on devices in the classroom, but you can also share them when teaching over Zoom, or project them on a whiteboard if you want to use these tiles in the classroom. If you want to create exercises for students, we have recently added a brand new feature right at the bottom here, which is the question builder. So we've got some input fields here, which I can drag out onto the canvas. Maybe change this back to 10 times 10 to show the 91 block. Let's add a question that says, what are the prime factors of 91? We've already added 2 answer fields here. Let's type in the answer, 7 and 13. And now I want students to actually play around with this and try things out. So here I've so far only been on the tiles tab where we have all of these different widgets. If I go to the library tab, I can give this an exercise, a name like homework, and I can save it to my library. And you can see here the canvas appeared. You can see I've already saved quite a few other canvases. There are also lots of example canvases below if you want ideas or just want to see what's possible with Polypad. So I've saved my canvas, and now I want to assign it to a class. So before doing that, I'll actually click on my face here and go to my teacher dashboard. I already have a default class in my account. I can create a new one like MathsConf demo. Oh, demo, here we go. And create the class. It has created a class for me. Right now, there aren't any students in it yet. I can import students from Google Classroom. So if you have classes and rosters set up in Google Classroom, you can really easily import students, and we'll create Mathicon accounts for any students who don't already have one. But for now, I want to use the class code here, which you can copy and share with students. So students can type this in when creating a Mathicon account. I'm going to switch to a different browser. And in here, I'm signed in as a student. And the student dashboard looks a bit different. You can see some of the Mathicon courses I've been working on recently, sort of how much time I've spent in the last week. And here, I can add a new class code. So if I type in join class, hopefully it should refresh. And it has added me as one of the teachers linked to the student account. And if I switch back to my teacher account and refresh the dashboard, you can see now I've got a student here, and I can even see some of their progress for different courses. But let's go back to Polypad. We can go back to the homework canvas, which we saved before with these 2 input fields. I go to the class menu. I will switch to the MathsConf demo class, and I will click Assign. So now this canvas has been assigned to my class, and lots of switching here. But if I go to the student version of Polypad, so again, I'm signed in as a student now. You can see there's no class menu. That's just for teachers. But we have this library tab. And the assignment is not appearing. Maybe I did something wrong. Okay, let's just take a look. I have linked my account. It has been assigned. Sorry about that. Let's see if it worked this time. No. Okay, so maybe there's a bug at the moment. We'll definitely be looking into that. But just like students can save polypads, they would see their assigned canvases here. And I wonder, because I have so many different accounts, whether it didn't link properly. But students can then complete these canvases. And here you can see I have one with these input fields, and it'll automatically mark and correct them, and then show you the students' results and scores on your teacher dashboard. In fact, let's just do that. Let's just copy the URL for now and open that. So as a student, I don't have the correct answers here. I can play around with this canvas, find the correct answers. I can maybe use the grid as well and help me count the number of columns and rows. And then I can type in 7, which is correct. And maybe this is 12. Oh no, let's keep counting again and then type in the correct answer. And there's a nice bit of confetti once you once a student completes all of the exercises in Canvas, and students can save their own copies of that. Okay, so this is how the sharing and yeah, here we go. So maybe now the linking has worked, but I can, once a student has completed the canvas, I can see their copy here, and I can see the answers they've given, the work they've done. If they've added additional tools or strokes to the canvas, I can very quickly see the work that my students have done, and I can toggle their name and progress on and off. So if if a teacher wants to share this in a classroom and talk about all of the students' responses, you might want to turn the names off so that it's anonymous and you can just review students' work, but then you can see your student's name. The progress bar shows what students have done correctly. Orange in this case means they took multiple attempts to solve one of these questions. And right now there's only a single response, but you can download, if you have lots of students, you can download all of this data as a spreadsheet as well. Okay. So in this case, if they change the order, it won't work. We are working on many additional features and different input types and having multiple answers that are linked. Maybe in the questions, just say to type in the numbers in increasing order for now. So some ideas what you can do with these number tiles and question builders, but in the number section, there are also lots of other components. So we've got the standard Cuisenaire rods, and right now you can see they are rainbow colored. If you click on the settings menu here, you can hide the labels if you want, and you can also switch to the more standard Cuisenaire colors if you want to use those. And again, just drag them out onto the canvas and play around with them. So you can select tiles and change the color to whatever you want and use them like you would any other manipulatives. I'm just going to refresh the page so that we have a clear canvas. If I want to use number lines, again, we've got components for this, just drag them out onto the canvas, and they, again, work really well in conjunction with these number bars. So right now you can see it doesn't quite line up, but there are lots of options for changing the size and labels of the number line. So I can move these handles here to make them wider or smaller. I can change the start position to anything I want. Let's keep it at 0 for now. I can change the width like this. So now you can see if the width is 1, just like the size of these number tiles, they work together perfectly. I can also maybe make it 10 and instead add 10 subdivisions like this, and then change the step size to 10. So now I've got labels every 10 units, and yeah, can use that again with the number bars. You can also use the number line together with fraction bars. So in this case, again, we need to just make sure that the sizing of the number line works out. So we maybe need to make this a little bit wider. There we go. So now, and change the step size back to 1. So now the 1 fraction bar tile lines up exactly with the 1 number line. And we have fraction bars up to 1/12. Like all of the other tools, just drag them out onto the canvas. And like before, you can split them up into individual tiles if you want to move them around. You can move the handle to change how many copies of a specific fraction you will. And one really cool new feature that we added recently, in fact, let's get rid of all of this and let's turn off the number labels like before. Here I've got lots of individual fraction bars, and let's change some of these to blue and some of these to yellow. And like the number tiles before, I can select all of these and merge them together. And if you do that, we interpolate the color. So if you have blue and yellow tiles, they mix nicely to become green. So if you want to talk about ratio problems and mixing problems with colors, these fraction bars, even with the labels turned off, are really useful. One of my favorite tiles, oh yeah, it can, there might be some delay between me seeing things and you typing things in, but you can absolutely, where did they go? You can absolutely have vertical number lines. Again, like all the other tiles, you've got the rotate handle here, and you can make it vertical or even from right to left if you want. And you can change the starting number to really big numbers, and it sort of rewrites the numbers to be nice and readable, even if they are very close together. My favorite tiles on Polypad are these prime factor circles. If you've played the game Prime Climb before, you might have seen some of these before and might recognize the colors. The idea is that for every number, we show the prime factorization, and I just need to turn the number labels back on. Here we go. We show the number labels as colors and these sectors around a number. So 12 is 3 times 2 times 2. 18 is 3 times 3 times 2. 2 is yellow. 3 is green. 5 is blue, and so on. All the small prime numbers have unique colors. Then they are all red or pinkish. And you can, if we have all of the numbers up to 24 here, but if you want to make bigger ones, you can just type in any number you want, and it is 2021. So I can create a prime factor circle for 2021. The really cool thing is that all of these number tiles are interactive. I can move them around, but I can also just take one of these sectors, pull it out, and drop it onto the canvas like this. So 12, if I take a 2 out, becomes 6, and I've got these two numbers separately. I can split up 18 into 3 and 3 and 2 like this. Do you know the prime factorization of 2021? You can split it up. It's very easy. 43 times 47. And one cool exercise there might be, when is the next, 43 and 47 are actually consecutive prime numbers. When is the next time that the year is the product of 2 consecutive prime numbers? And students can maybe guess the answer, and then we can try to work out the solution. When was the last time the prime number before 41 is 43 is 41? So we can add that. The next prime number after 47 is, it's not 51, 53, I think. There we go. It's 53. And we can recombine these numbers together simply by dragging and dropping them onto each other. So I can multiply all of these numbers together and recombine them. And 41 times 43 is 1700. So a long time ago that this last happened. And the next time will be in 2491. So lots of different things you can do with these prime number circles. And again, you can create your own worksheets and exercises using the question builder. One thing that's really cool is maybe to find all factors of a specific number, like 18. So we've got the number 18. We can pull out 2, and we've got 2 factors. We can pull out 3. We've got another factor pair, 3 times 6, like this. We can split them all up into individual numbers. So 18 is 2 times 3 times 3. Oh, and I forgot to keep in the original number. Let's add that back in. So very simply like this, we can, and of course, we can just keep all numbers combined together. You can use the 1 tile for that if you want to represent that as a multiplication problem as well, maybe. And then sort of create a, let's use the straight line for that. And yellow might be misleading. Create a tree of different factorizations and factors for these numbers. Yeah, so again, just a couple of ideas. There are many other things to try out and use these prime factor circles for. I'll skip these number cuts for now, but come back to them later when we talk about algebra. But essentially, they work very similar to the prime factor tiles, except for addition. So I can have a 3 and a 4. If I drop them on each other, they become a 7. And like before, I can create larger or smaller numbers if I want to. I can create even negative numbers. And if I want to subtract 7 from 2, I just drop them onto each other, and they become 5. So we'll come back to these. Another really cool component is the multiplication grid. And let's turn on the grid background for this, maybe, to make it easier to see. So here I've got a grid that visualizes the multiplication of 23 times 12. I've got the big yellow square is 10 squares by 10 squares. I've got 3 more, and I can multiply them together and use this as a visual way to represent the multiplication problem. And like before, I can move these handles to change the first factor and the second factor of the multiplication problem and represent different problems. I can maybe use these number bars to show what's going on. So we've got 20, in this case, is that a 7? No, it's a 6. Let's make this a bit bigger. 27, and I've got 14 along the other axis, so I can use these Cuisenaire bars as labels. One thing that's pretty cool is that you don't have to multiply in base 10. So we've got this other handle here in the middle, and you can change the base of multiplication. So if you want to multiply in base 8, for example, you just have to make sure that the big squares are 8 tiles wide. So let's just check. Yeah, they're 8 tiles wide. And now I can multiply, I don't know, 22 times 12 in base 8. And you can use use these for all sorts of different bases and multiplication problems. Or you can use these for decimal multiplication. So if we change this back to a 10 by 10 big yellow square, this could be 23 times 13, but it could also be 2.3 times 1.3. And you can use this grid to visualize multiplying decimal numbers, or even fractions. So let's use the number line again. And let's drag this out. We only need this. We make the width of 10 individually. Actually, no, let's make them a width of 3. Let's change the base here. And so we've got a completely different multiplication problem now. But this is essentially 2 2/3 times 1 1/3. So depending on which unit you use as the base, or how you resize the number line, you can visualize all sorts of different decimal or fraction or integer multiplication problems here. And just to finish off the number section, we have just added a preview version of exploding dots, which again you might know about. There have been previous MathConf talks about it. It says preview here, which means we're still working to improve it and adding more features. But let's turn off the grid background again. I can create one of these dot machines. I can again change the base. Right now it's base 10, so you can see I've got ones, I've got tens, I've got hundreds down here. And then I've got these dots, and I can drag them into one of these boxes. So I've got 1 dot in the tens box now, and the total number is 10. I can take this dot and drag it into the ones box, and it becomes 10 ones. I can also add anti-dots that are red and negative. I can select the box and annihilate duplicate dots like this. So 10 minus 2 becomes 8. And again, do lots of cool things using exploding dots. Okay, so we've talked a lot about these different number widgets. Let's go back to geometry. So we've already seen how to create different tessellations. And you can see we've got regular polygons from 3 up to 12, and lots of cool exercises here. So can you make a tessellation using this 12-sided polygon? And there are actually a few different ways to do it. For example, using hexagons and squares and dodecagons, 12gons. But just talking about the angles of the polygons meeting at this point can be really interesting. And you can use the pen tool to annotate this and sort of add up the angles. And we've got 90 here and I don't know, 120 here. Can we use that to calculate the internal angle of this dodecagon? We can also use these utensils we have down here. So we've got a ruler and a protractor. Let's use the protractor for now. And it works basically like all of the other tiles. I've got 2 handles here. Let's make sure the first handle snaps to one of these vertices. We can move the other handle also to resize this, but let's keep it level for now. And then if we zoom in a little bit, we can very easily measure the size of the internal angle of the dodecagon, which is 150. Like I said, we also have rulers, and again, they have these handles. You can move them around and measure different distances in geometric constructions you've made, or you can just use them to draw straight lines in. So if you draw with your pen tool close to a ruler, it draws a perfect straight line. There have been a couple of questions about guidebooks, and I'll come to that later. But yeah, we've got guidebooks, and we've got quite a few tutorial videos as well that might help you with that. One question at the very beginning of the talk was about resizing polygons. And with these normal regular polygons, that's not really possible, because if you imagine these are physical shapes, you also couldn't resize them. And we really want them to fit together nicely and preserve area. But there's a workaround. So you might have seen here in the polygon section, we've got these regular polygons, we've got the normal pattern tiles that we've used before. And again, if you use a different color scheme, you can switch to maybe a slightly more common color scheme where triangles are green. But let's go back. And there's this weird one, which is kind of irregular, and it has dots in all, at all of its vertices. And this is a custom polygon. And I can move all of these vertices around to create any type of polygon I want. If I click on a vertex, it disappears. If I click somewhere on an edge, it adds a new point. And then I can also just click and drag on an edge if I want more like this. So if you want, we've got this equilateral triangle. If you want to create a larger equilateral triangle, I would recommend turn on the isosceles, the isometric grid here. Let's delete some of these points we don't need, and just snap the points to the vertices to the point on the isosceles grid to create a larger polygon. And then I can click the lock button here to sort of lock it in place, make it a normal polygon that can't be resized. And then again, you can create copies of this and create larger tessellations or do other things with this. And one thing that lots of teachers do is create specific types of polygons they want students to use, just save it to their library and then share the link with students so that they have a starting point, a template canvas with these specific polygons set up to create new things with new tessellations, solve new problems. You can, of course, also use the other existing polygons as helper tools to create new ones. So if you want to create a star polygon, for example, we can use this square as a helper. Let's create some vertices that snap in here like this. Let's also use the hexagon maybe and rotate this like this. So I can make a little corner here. And now I'll rotate the square again and do something like this. So this should fit together like this. And maybe you can see where I'm going already, but sort of just by moving these existing polygons around, and because they all snap together, you can, oh, that was the wrong one, create stars and all sorts of other polygons. You could show students that any quadrilateral tessellates, so let students maybe in class together create some weird looking polygon like this. Let's just lock this in place and create a copy, rotate this around. Again, all of the edges should snap to be perfectly aligned, like this, for example. Let's maybe change the color of this. And then we can zoom out a bit, create a copy of those two and move these over here, move these over here. And it turns out that even this weird kite shape tessellates perfectly. And the same, of course, is true for all triangles. So you can use these custom polygons to create really anything you want geometrically. But there's a different way that we added pretty recently to create your own custom polygons and play around with these. And that's the cut tool. So I just add an octagon here maybe. And you can see I've got a cut button here. I can click this, I can drag a line, and it cuts the polygon into two parts that I can then move around separately. And this is incredibly useful if you want to talk about area or area of polygons. So with the grid background, for example, let's create a parallelogram like this. Let's lock it in place. And you can ask students, how do you find the area of this? It's easy. You use the cut tool. It snaps to vertices of and grid points, of course. You cut off one of the triangles here, move it over to the other side. Now you've got a perfect rectangle. You can count the number of squares or use the ruler tool to measure its base and its height. And then you can work out the area of this parallelogram. And yeah, you can see I've got lots of tabs open, which I forgot showing previously. But we've got some exercises like this, for example, with differently rotated or aligned parallelograms and quadrilaterals and triangles. And just by cutting it up, or rotating it in place, students should be able to very quickly find the area of all of these, type in the answer, and of course, like before, you can use this, share it with students, or create your own exercises like this. It's not just the area of quadrilaterals. We can also talk about Pythagoras. So let's create a triangle like this, maybe. Let's get rid of those 2 points, maybe a bit smaller to make it easier. And we create a square on one side of this triangle. How many tiles is this? Like this. And we create a copy and create 1, 2, 3, 4. 1, 2, 3, 4. Another square on this side. We'll take all of these and lock them, maybe change the color to make it more, a bit more visual. And now let's see if we can cut these 2 squares to create a third square on the hypotenuse. So again, let's use the cut tool and go down 1, 2, 3, 4. So parallel line to the hypotenuse like this. And now we select both of those again. You can cut multiple shapes at once, 1, 2, 3, 4, and cut a perpendicular line like this. And let's see what happens. We can move this shape over here. We can move the square over here. In fact, I'll just turn off the background to make sure they snap to the correct places. We can move this little triangle over here, this big one over here. And just like that, we've proven Pythagoras' theorem. And I really like this because of how tactile it feels. And students should see immediately, it's obvious, as I move these tiles around, we don't change area. There's no weird dynamic geometry happening in the background where you have to trust the computer that what they're doing is right. Just like with a piece of paper and scissors, you can do anything you want yourself, cut things up, move them around. Another cool example of this tool is, this has been very popular on Twitter recently, I think. Let's create a larger square like this. Is this a square? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and we'll cut it along the diagonal like this. And we'll select both of those and cut them along the other diagonal like this into lots of smaller quadrilaterals. And let's turn the grid off again. And now I'm going to show you a magic trick. I'm going to take this tile, move it over here, and rotate it a little bit. Let's rotate this a little bit and snap it in here. Let's rotate this tile a little bit and snap it in here. And we've created another square using exactly the same tiles, no resizing going on here, that has a hole in the middle. And you can ask students about where the hole came from, or maybe use a ruler to measure the width and height of this new square and talk about the difference in area or something like that. Another, if I can find the right tab, nope. Here we go. Another really famous magic trick like this that probably you've seen is we've got this triangle. You move the tiles around. They look exactly the same. We snap them into place, and suddenly we've created a gap in the triangle. Where did that gap come from? Or how does this one work? We need to rotate this one, I think, like this. We rotate this one like that. And in this case, there's no gap. But before we had 5 times 13 squares, which is 65. Now we have 8 times 8 squares, which is 64. And again, where did the additional square go to or come from? So lots of cool and fun things you can do with these polygons. Other than the built-in ones, we also have tangram shapes. We've got the classic tangram. We also have an egg-shaped tangram, and a completely separate page just with lots of puzzles you can do with tangram. We've got different pentominoes and tetrominoes that you can do different exercises with. And yeah, just a few different ideas. We've talked about this one. Let's close this. We've got all of these different animals that can be made using all of the pentominoes. And this, of course, is kind of the solution. So instead, you can maybe go around with the ruler tool, draw the outline of one of these shapes, which hopefully won't take too long. Well, you get the point. We'll cut off the line set there. So create the outline, delete all of the individual tiles, and then make it an exercise for students to fill in the shapes. And one really interesting puzzle is this one. We've got a calendar with the months from January to December and the numbers from 1 to 31. And we've got a couple of pentominoes. And can you arrange them in a way that only today's month and today's day are left empty? So today is March, and it's the 13th of March. So we need to leave this one empty. Maybe we can move this one around. So we get a different pentomino puzzle every day for students to solve. And I guess this doesn't work because I've got this 2x2 block here left with no pentomino that would fit in here. But maybe you or your students want to puzzle around with this later. So yeah, we've got pentominoes, tetrominoes. We've talked about the different drawing utensils in geometry. There are Penrose tiles, which are non-periodic tessellations, where in this case you have to make sure that the circles drawn on top of these tiles line up whenever. So here you can see these arcs continue. And if you create a tessellation using these tiles with this specific rule, it's aperiodic. That means it will never repeat, no matter how much further you keep adding tiles, which is very different from some of the more regular tessellations that students might have created previously. And there's a differently themed version of, again, Penrose tiles with nature. So I've got a butterfly here, and let's create another butterfly and rotate it, and that might fit in here. And I can fit a flower maybe in the middle like this. So again, students can create these really cool tessellations using these nature-themed tiles and create a non-periodic tessellation. Kolam tiles are a traditional type of artwork from India, where girls and women traditionally draw these really cool shapes using grains of sand or rice in front of their buildings. And yeah, there's a lot of mathematics here and symmetry, but you can create these kolam patterns using the tiles we have created. We've got some fractals, which you can use. We've got tantrics tiles, and yeah, almost every week we add new tiles and components and widgets for you to play around with. But I'm just slightly conscious of time. We don't have that much left, and I want to leave a bit of time for questions later. So what haven't we talked about? Probability. Yes. Maybe the most fun part. So we've got a few different probability tools. We can drag some dice out onto the canvas. Let's maybe create a 2x2 grid of dice like this. Let's select all of them. Let's zoom in to have a really nice animation. That probably won't come through on Zoom, but you can try it on your own computer later, and we can roll the dice. And yeah, it's random. It gives you the results. What's very powerful about this is that you can create lots and lots of dice very quickly. So we've got 4, we've got 8, we've got 16 dice. Very quickly I can create grids of 100 or more dice for students to roll and generate a lot of probabilistic data with all of this. And if you can imagine every student doing an experiment on their own screen in a classroom, you get lots of high numbers, which means that the results will be very accurate. We also have coins with just 2 sides, a star and a head. There are spinners, 2 different types of spinners. We've got these uniform spinners where you can just change one handle and you've got a uniform set of regions, and click randomize and it will spin the spinner. But just like we have custom polygons, you can also create your own custom spinners. So click on the border to add points on the spinner, or just drag them out or click on them to remove them, and you can move them around and create whichever kind of spinner you want, and then randomize and roll it. Rather than the normal dice, we also have non-transitive dice. So you can see the nets here. There are 3 different sets of non-transitive dice. Again, there are previous MathsConf videos you can watch about what non-transitive dice are and why they are so interesting. But yeah, if you want to actually have real-life versions of them or virtual versions of them to use in real life, add them and roll them and see that. I think in this case, red always beats blue, blue always beats, or on average always beats green, and green always beats red, kind of like rock, paper, scissors. So I wanted to show you a couple of examples of what you can do with these dice. So here is a probability tree, for example. You flip first a coin, then you flip a die, and you respond the outcome. What's the probability you get a star and a 1? So this is the probability tree. Let's select all of these examples. Let's roll all of them, and then we can see where do we have a star and a 1. Here we go. I think this is the only example, but you can yeah, set up any experiment you want and then roll the dice and see what happens. A really cool game is called, let's save those changes, is the Genius Square. So here I've got a 6x6 grid sort of coordinate system, and I've got a couple of spinners. And I want to spin all of these, so let's just select all of them. Again, I'm holding the shift key at the moment to select all of them. Let's randomize all of them. And now let's look at the answers. So I've got one answer that's C3 here. So let's move one of these black squares into C3. And it's a little bit cut off. Let's zoom out a little bit. We've got C5 back here. Let's move a square in here. That didn't quite line up. We've got, in fact, maybe I need to enable the grid background for the tiles to snap. We've got A5. We've got D5. We've got C2, just about. We've got E2, and we've got A6. So we place these black dots in here, and now we've got a puzzle. We need to put all of these other shapes in this grid without covering up any of the black squares. So we could put the blue one here, the red one around here maybe, and it's a very cool way for students to generate their own shapes and puzzles and games. And I've seen teachers ask students to just come up with their own games using all of the different tools we have in Polypad, save them to their library, and then share them with their classmates. Okay, we've talked about Genius Square, we've talked about magic tricks. Visual patterns is a great way to use the geometric tiles we have. So if you go to the website visualpatterns.org, there are literally hundreds of patterns which we can use to start talking about algebra. And here is one of these, number 19. And the goal is for students to find an equation that represents the number of squares in one of these components. And students can do this on their own. They can share their screen over Zoom, maybe in breakout sessions in different rooms, and try to find interesting ways to represent this. So for example, you could split this up into x here, and we've got x plus 2 here, and we've got x squared here. And this is one way to represent this using algebra, if sort of x is 4 here, x is 3 here, and so on. But you can also move the tiles around. So we could take all of these and rotate them over and move them here, for example. And we can take this and move it over like this. And now we have x plus 1 squared plus 1. And if you expand those brackets and simplify it, hopefully you should get the same result as before. But there are lots of these cool ways to manipulate the squares and find different algebraic representations. And talking about algebra, just the last topic I wanted to talk about, which we haven't covered yet, is this algebra section here. So we've got coordinate axis while this is open, which you can drag out, like the number line. You can sort of change the step size along the x and y axis. You can move the handles to change the width, whatever you want to have, maybe just the first quadrant like this. You can use this with geometry tiles, for example, if you want to create a geometric shape on a coordinate system like this. But let's delete these and go to algebra tiles. So let's drag out just a table like this, and we can create, I'm sure you've all seen algebra tiles before, but we can very quickly create multiplication problems using these algebra tiles. And let's add some ones here. There we go. We just need the labels at the top. So we've got x plus 3 and x plus 2. You can drag and select multiple of them and then click negate here at the bottom if you want them to be negative. And you can see they all turn red. And then if you take one of these red tiles and move it on top of one of the green positive x tiles, for example, you can see they cancel out. The same goes for ones, of course. You can move them on top of each other and cancel them out. And then if they, if you don't want them anymore, just delete them. Otherwise, leave them in light gray. And the same, of course, also for the x squared, if you have multiple of them, to cancel them. So you can use this to talk about algebra, but also just very simple division. So if you have 5, 6, 7, 7 minus 2, just move them on top of each other, and you're sort of left with the correct answer, which is 5. So even for younger students, you can use these algebra tiles. And if I get rid of all of this, the last component, again, this is in preview. We've gotten lots of emails from other features that teachers want to see here, and we are working on them. But you can create one of these balance scales. Right now it's in balance. I can take one of these components, drop it on this side. Now it's no longer balanced. Maybe have 2 of those here. And then, and now comes the interesting part. So we can use the number bars, for example, and put a 9 here. Actually, 9 is an odd number. That's probably not so convenient. Put an 8 here. Right now, the balance is not balanced. So if I select it and click the balance button down here, it will calculate correct values for all of the variables, like these weights, for example, to make this work. And now we can say, if we move this over, it's no longer balanced. If we make this a 4, for example, it does work. And we can use this with the where were we? With the number cards as well. So if we have x as the weight, for example, plus 3 is equal to 8, we click balance, and we've created an equation like this. Now we just need a minus 3 tile, which we drag out, and we create a copy of it, and we add minus 3 to both sides, and the scale stays in balance. And if we drop those on top of each other, they sort of cancel out to become 0. And if I drop those on top of each other, they become 5. So the weight is 5. So yeah, you can use this balance scale with all of the other components we have, even prime factor circles. If we put 11 here and 15 here, if we now click balance, it'll tell you it's impossible to balance those weights because there are no variables for polyped to sort of assign values to. But if we use it with algebra tiles, for example, and let's say x squared plus x, I don't know, is a couple of ones like this. So we create an inequality like this. Right now you can see it is an inequality. If I select all of these tiles and click negate, you can see the inequality switches signs, because if you multiply numbers on both sides of an inequality by -1, the inequality changes, of course, changes direction. So yeah, we have just 5 minutes left. So I don't have any other content to talk about, but if you have questions, please put them in chat, and I'll try to answer them. Like I said, if you want to save things to your library, I just created this using fraction circles for Pi Day to calculate the area of a circle by splitting it up into these different sectors. You can save it to your library. You can then assign it to a class, or you can click on share here and copy link, assign it to Google Classroom. You can even, if you run a WordPress blog or some other website, you can generate an embed code. So you can customize the tiles you want students to have in the sidebar, or we can hide the sidebar entirely. Maybe we only want the move tool in the toolbar at the bottom. No settings, you can't delete tiles. We can change the width, and it generates an iframe embed code that you can use on other websites. And again, for non-commercial purposes, that's completely free to use if you want to add virtual manipulatives to your blog or website. Okay, so that's everything I had for today. But email me if you have questions, message me on Twitter, or put any questions in the chat for the last couple of minutes.
Hi, Philip. So I've got one question in the Q&A for you, if you'd like me to read it out for you.
Yes, that is off the corner of my screen. I couldn't fit everything in. Yes.
So it was from a little while ago, so hopefully the context is clear. So it's from Michael, and he says, do you think students need to be fluent in a topic, in brackets atom, before they can reason and problem solve with it?
Absolutely not. I mean, the whole purpose of Polypad is for students to become fluent in topics and use this as a very visual, very concrete representation while they are still developing the more abstract thinking skills using equations and algebra. The whole purpose of Polypad is to have a very open-ended playground for students to discover things on their own, play around with components and tiles, and see what they can discover, see which patterns and relationships they can find.
That's great, and I think that's all in the Q&A. So unless anyone has any other questions in the chat, it just seems to be people thanking you at the moment.
You're very welcome. Yeah. So last 3 minutes. One thing I can also share is this is Pascal's triangle built using prime factor circles. So you can, if we zoom in a little bit, you can see that every circle is the sum of the two tiles immediately above. 15 is 10 times 5. But why use this? Why use the prime factor circles? For this, you can sort of see that triangles appear. So we've got a big purple triangle here of 7s. Every circle in this triangle has 7 as a factor. And we've got a huge 11 triangles starting just about here. Even the 2s, all of the yellow numbers appear as triangles. So you can think about why that is the case. If you add 2 numbers divisible by 7, the sum will also be divisible by 7. And with 2s, you can even create Sierpinski's triangle, and I have saved that as a separate canvas, just a cool version of Sierpinski's triangle using lots of individual tiles. And again, this was very easy to create. I just select one corner, create a copy, move it around, and drop it in place. And one important thing at the end, maybe, we have these examples. We have some help instructions down here. So a user guide, we've got all of the different keyboard shortcuts, which are especially important for students with accessibility issues that might not be as comfortable just dragging things around or drawing with a pen. So we've got lots of keyboard shortcuts for everything. And we've got a whole library of tutorial videos and instructions and lesson plans you can download. So here are quite a few PDF lesson plans to download, and then video tutorials for example, how to share and assign things in Google Classroom, or how to find different factors, or integer addition using the algebra tiles. So lots of videos to help you use Polypad. And that's all at mathicon.org/teachers.